This question asks us to use logarithmic differentiation. So take a log of both sides. You could use common log, but natural log is going to be easier when we eventually evaluate the derivative. So took a logarithm of both sides, and the reason why that helps us is because we can use the properties of logarithms to rewrite. When you have something divided by something inside the argument of the logarithm, it's the top subtracted by the bottom in the logarithms. So that's just a property of logarithms. It's not a calculus trick or anything like that. And then we also have the fact that this is a 1/3 power. So if your entire argument's raised to a power, you can move that power to the outside. That's a logarithm property. So we move that cubed root to the outside because of the exponent property of logarithms. And so now that we've got it as expanded as we can, now we can take a derivative of y with respect to x. So watch out here, the derivative of y with respect to x, there's an outermost function. The derivative of natural log would be 1 over the argument, but then the derivative here with respect to x is y prime. So because of the chain rule and using implicit differentiation, this is the derivative of this term. The outermost function, the derivative gives us 1 over y, but the derivative of the innermost function with respect to x, we don't know what that is explicitly, so we write it as y prime. And then derivative of this term with respect to x, that's just 1 over x plus 15. Chain rule doesn't give us anything other than times 1 there. The derivative of this term, it's 1 over x squared minus 9. But this time the chain rule does give us something. The derivative of the innermost function is 2x. Right. Okay, so our goal is to get y prime by itself because we're trying to find a derivative, so we can multiply both sides by y to get it out of the denominator here. So we got y times all this stuff. But we want things in terms of x, and we can do that because we know what y is. Back up here it says this is what y is equal to. So we can plug in, sorry, there's supposed to be a parentheses there. We can plug in our original function in for y, x plus 15 over cubed root of x squared minus 9. That's getting multiplied to all this stuff inside parentheses here. I'm not sure what would be cleaner, to leave it like this. I guess if we distribute, these would cancel. I think this might be as clean as it can go. But I'll pause the video, play around with it, and if I can figure something else out, I'll continue the video. I think that's it.